So on worksheet 1, I think we got to the very end. We started talking about, was it conditional probability at the end, maybe? This was the last thing. Honestly, like I said yesterday, I don't ever use this formula where it's talking about union of probabilities. You can find the probability of A plus the probability of B minus the probability that A and B both happen. I don't ever do that. I just figure out how many total winners there are. So on a question like this, worksheet 2, says in a math class, there are 14 seniors and 8 juniors. 5 of the seniors are male. What does that leave? I think we're going to need to know kind of questions here, or the rest of this information. If there's 14 seniors and 5 are male, that means 9 are female. Everybody with me here? 8 juniors, 4 are female, so that would mean 4 of the juniors are male. So what is the probability we pick someone out of the class and they're a senior or male? Well, how many seniors are there total? And how many additional junior males are there? 4, right? So that's a total of 18 are seniors or male. We could have done, all the males and then added additional senior females, but somehow we need to figure out the total number who are winners according to this. And then there were 22 total in the class, right? So that would reduce to 9/11 if you were writing it as a fraction. Junior or female? How many total juniors? Okay, and how many additional females? 9 senior females, right?
Oh, right.
So that's 17 out of 22. We certainly could have made a little chart that would have helped here. Junior, senior, male. Yikes, sorry. Female. If we had put this in 14 seniors, so there were 5 male and 9 female, and 4 and 4 for the juniors. So for this question, senior or male, we need the 5 plus the 9 plus the 4. Okay, that's where we got 18. Junior or female would be juniors all count plus additional females here. So we had 4 plus 4 plus 9. All right, junior or senior? According to this, everybody's either a junior or senior, right? So it's just 100%. Number 5 says, your doctor is going over the statistics of a risky operation. The surgery has a 25% failure rate, okay? %75% would be success then? Everybody good? 1 minus, okay. If the surgery works, so that would be off of success, there's still a 17% chance of infection. The surgery can fail and you can still get an infection 3% of the time. So if you did failure, you could have an additional 3% infection. Okay. What are the chances of a successful and infection-free surgery? So if you were successful, what's that percentage? This is two independent. So we're just going to multiply the probabilities. So success was 0.75. What's the chance if you're successful that you're infection-free? 17% is infection, so what would it be? No infection. Yes. 83%. A tree diagram would be helpful. That's kind of what I'm trying to do here. So 0.83, I don't know what that is. Somebody helping me out? Okay, so your chances of a successful infection-free surgery are about 62%. Now, if we had done this, again, we could have said success and failure, and then we could have said infection, no infection. And then we could have put those percentages on there for a little tree diagram would have worked as well. All right, number 6 says at a clothing store, statistics show that if you just buy pants without trying them on, you have a 30% chance of them being too tight, a 10% chance of them being too loose. So what's the probability that you purchase pants without trying them on and they actually fit? I think all we need to do is subtract, isn't it? I think it's 60%, yes? Okay. It's a weird question. Number 7, to meet state standards, Harlem does research and discovers that 80% of students need help with math, 70% of students need help with English, and 55% of students need help with both math and English. Anybody have any ideas how we could try to figure this out? My idea for this one was kind of a Venn diagram. So we have everybody at Harlem, everybody who needs math help, and everybody who needs English help. But what is this percent that overlap? Yeah, this is 55%. Okay, if this circle is math and English help, they overlap at 55%. What is out here for math? No.
No, wait, 45.
Yes, because you can't have 80 plus 55 and have over 100%, right? Everybody in this circle should total the math of 80%. So this would be an additional 25% out here. 25 and 55 would be 80. All right, 70% need help with English. So what's the additional English besides the 55? All right. Now, the question says, what is the probability that students need help with math or English? This is hard for students because it's not clear what it's asking. When it says math or English, that means including both. Okay? So it's like saying, if I said, are you wearing white? Are you wearing black? If you're wearing both, you would still say, yes, I'm wearing white or black. Okay? If you need help with math or English or both, you're going to qualify as being counted for here. So you would have 25, 55, and 15, which is, anybody? I think it's 95. Yeah, it's kind of a ridiculous question. I hope 95% of students don't need help meeting state standards, but it says Harlem, but it's just a made-up question, so. We good? So the issue here, guys, you need to understand that when it says or, it includes both. All right, so conditional probability, and these are the ones that students struggle the most with when we get to the quiz on this. Conditional probability says find the probability of an event happening given the fact that another event has already happened. So the first one just says probability that you choose an independent person. So we have Democrats, Republicans, Independents. We have executives, production workers, and then a bunch of totals. So here's the initial data. And then we got a bunch of totals out here. So what is the chance we pick somebody who's independent? Yep. I don't know if that reduces. I'm just going to go with no. Okay. It does reduce it, but production workers. So what is the total number of production workers? Production workers is this one, right? 92 over 140, which would reduce. 46 over 70, which would reduce again. Is it 23 over 35? Yep, that was a guess. Okay. Now, here's our first or. It says independent or a production worker. So you win if you're a production worker. So we need to count all of those. Plus you win if you happen to be just a plain independent, which would be these. Does everybody understand when it says independent or a production worker that we want to count all of those? Okay. So the easiest way, in my opinion, would be to do the 92 plus these 9, right? All the production workers plus 9 more independents, which is what, 101 out of 140? Everybody okay? All right, these are the two that I'm worried about. When it says given, guys, this is telling you the total. Okay, executive given that they're Republican. That means you can only say out of these 55. Because given they're Republican means you are only looking at these 55. So executive would be 34 out of 55. Everybody all right? So what is this total going to be given they're a production worker? Yeah, independent would be 8 out of what though? 92. Given the production worker, this is going to be the total you use because we can't include all 140 people. If we know it's a production worker, we know we're down to these 92. Okay? So the given part tells you what the denominator is. It says that right up here. It says probability of A given B, and it can be written with this little line in here. We don't usually use that. We just use the words. And it says you find the probability of A and B, and then you divide it by the given part, the B. So the number of independent production workers, that was A and B, that was 8, but then you divide it by the total number of production workers. All right. I'm not going to make you on a test or quiz do a tree diagram. It says if you flip a coin, well, you could get tails or heads, right? But then when you roll a die off after that, you could get, I don't want to write all these, do you? 1, 2, 3, 4, 5, 6. Okay. 1, 2, 3, 4, 5, 6. And you could have definitely done the die first and then the coin. It doesn't matter. All right. So if the question was now use your tree diagram to figure out the probability of getting heads with an even number, you'd say, well, this is heads with a 2, this is heads with a 4, this is heads with a 6. So there were 3 winners out of a total of, and then you count the total at the end here, which would have been 12. So you'd get 1/4. You could have just said, what's the chance that I flip a head? And what's the chance that I roll an even number? So you get this answer, okay? Because those are independent events. All right. Now we're going to talk a little bit about permutations and combinations. This is a struggle for students. The first couple are just called counting principle questions. In a class of 30 students, they have to choose a president, a vice president, and a secretary. A student can only hold one position. How many different outcomes are possible? So I always draw myself a blank, say, okay, I'm going to choose a president, a vice president, and a secretary. So the first time I go to pick, I have 30 to pick from. But now whoever won can't be in the next round for vice president. So I'm down to 29, and then I'm down to 28. It doesn't say probability. It says how many different outcomes. So we're not doing like 1 over or anything. We're just finding the total number. And I don't know what that is. Did anybody type that in? Did I get it right? Is that what you said? Okay. Oh, revisit the 4 children problem. Create a tree diagram showing the possible outcomes. Yep, I'm going with no. Do you remember the tree diagram I showed you yesterday for the 4 different outcomes if you had 4 kids, or how many outcomes there were? It was this. Do you want to draw that on your paper?
No.
I'm voting with no. But the idea is all it asks in the end is how many outcomes are there. So just like I showed you briefly yesterday, if you're having 4 children, you have 2 possible outcomes for gender for each of the 4 children. So there's a total number of 16 possible outcomes. How long do you think they'll be before we can't ask gender questions? Yeah, I feel like it's not appropriate even now to assume everybody's male or female. Anyway, moving on. Permutations and combinations. There is a fancy formula, but what you really need to understand, because you get to use a calculator for this, you don't have to memorize the formula, but you need to understand the difference between these. Okay? Permutations is when there is some kind of priority, that's the word I remember, or order matters. Now, it doesn't necessarily mean order matters so much as that you want to count differently. So here's my example, okay? Zoe, Kayvon, and Tristan are going to be a team. Do I want to count that the choosing of that team? Would I want to list, sorry, Zoe, Kayvon, Tristan, Kayvon, Zoe, Kayvon, Tristan, Zoe, etc. Do I need to list those all differently? If it's just a team, I only want to count it once, right? It doesn't matter what order they were picked in, they're just on the team, okay? That would actually be a combination question. Permutation, where order matters, is if I said, I'm going to pick and I'm going to give the first person I pick $100, Kayvon, and the second person I pick $5, Zoe, and the third person I pick a quarter, Tristan. But do you get the idea that then it matters what order you're picked in? Okay. So it doesn't matter what order you're picked in if I'm just going to put you on a team. And the word I don't usually remember the word team. I remember committee. I hope I spelled that right. Because committee goes with combination, right? If I'm going to put them all on one committee, it doesn't matter what order I picked them in. They're just on the committee. Permutation or priority would be like if I'm going to pick a president and a vice president. Whether you're picked first or second matters, okay? Whether we're stuck with Kayvon as our president or Zoe as our president are 2 different things, right? Do you kind of understand what I'm getting at here, guys? All right. So which of these is going to be a bigger number? Okay. The bigger number is going to be when order matters. If I want to line you guys up in the door at the door, just think about this easy question. If I'm going to let you line up at the door and I'm going to count how many different ways I could do that, there's going to be a lot of different ways, right? But if I say, as a class, we are going to go in one group to the library, and I don't care about what order, then there's just one way, right? We all go. Okay. So if order doesn't matter, it's going to be a smaller number because you're not counting things differently. Order matters means you're going to count things differently, so you're going to get a bigger number. Now, by smaller and bigger, what I'm saying is if we had 30 students and we wanted how many ways can I pick 3 of them to give 3 different prizes where it's $100, $50, and $10, that's a permutation question. Okay. If we wanted 30 ways, 30 students, and I'm going to give the same thing to 3 people, okay, I'm going to let 3 people leave early, we'll say. Doesn't matter what order you were picked in, but you get to leave early. So I want to show you how to do those on the calculator. Permutations and combinations, you can use this lovely formula over here, or you can go to the math key, and we're doing probabilities right now, so we have to go over to this one. You can either go left or right, it doesn't matter, it'll get there to this one. And number 2 is permutations, and number 3 is combinations. Now, if you have the calculator operating system I have, it'll let you type in the boxes afterwards. If you have an older calculator, you have to put in the 31st, I think. So if 3 people are going to get a big prize, one's going to get 100, one's going to get 50, and one's going to get 20, there's 24,360 ways it could happen. Okay. But if there's 3 of you, and this time I put the 30 in first, it doesn't matter. Go math over to probability, and I'm going to pick number 3, the combinations. If I'm just going to pick 3 of you and let you each leave early, doesn't matter what order, then there's only 4,000 ways I can do that. Well, if there were 30 of us, there's not 30 of us here, so that's why it seems really high. Do you understand why this one was more then? This one says, I'm just going to lump 3 of you together, and doesn't matter what order you were picked in. You're all going to get the same thing. P was priority, where there's some reason you want to be picked before the other 2. Okay? Priority. Now, there is a shortcut, and I don't remember where it is. I think it's alpha. Good guess, Hofbauer. It's alpha window if you have a newer calculator. Did everybody find it? Alpha window, and then it's numbers 7 and 8. Just because it's a little less strokes, okay? Alpha window, 7 and 8 will give you that same thing. I never use it. We're going to go back and finish the worksheet here real quick. The bottom, it says you have 32 people in your class. You're choosing a team of 3. Permutation or combination? Combination, because it doesn't matter what order they were picked in. You just want to know how many different ways you could pick a team of 3. So was it 30 and 3, guys? Were those the numbers? Oh, we just did that one then, right? Okay. 32 and 3. So it's 4960. All right.
Do you have to label?
No, I wouldn't care. Number 2, how many ways can 8 students be placed in line? Yes. In permutations, makes sense to me because I can also do this. If I have 8 of you, I look at the group and say, well, there's 8 people to pick for the first position, and then 7, and then 6, and then 5, and then 4, and then 3, and then 2, and then there's one person left for the last position. This is going to be the same answer as 8p8. By the way, this is actually called 8 factorial when you multiply 8 on down. All right, so real quick, on your calculator, under the math menu, it's number 4. You could have picked 8 factorial, or you could have picked out of 8. Oh, I'm going to sneeze. Number 2, 8. Or you could have just done 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now you know better ways, right? Okay. Was it 343.20? Or no? Did I totally remember that wrong? Okay. Number 4, in how many ways can I arrange my videos and DVDs on my shelf if I have 5 videos and 7 DVDs, and all the videos are going to stay together and all the DVDs are going to stay together? All right. This is just a weird question, but apparently order matters. You know, I don't want to put them together, and I don't know. But it says I have 5 videos, so I'm going to put all 5 on the shelf. Okay. So 5p5. And then I have 7 DVDs, and how many different ways can I put them in order? And then because I don't know which one comes first, I think I multiply these. I'm confusing myself. So what's 5p5, guys? And 7p7? What's 7p7? Should be 7 times, this is not 5, is it? Should be 5 times 4 times 3 times 2 times 1. And this one? Okay. Now the question is, do I multiply those together? I have to keep these together, and I have to keep these together. I still think I do because, yeah, I'm confusing myself. Just multiply them together for now, and I'll double check it tomorrow. I did? Okay. Oh, that was the answer for, thanks. This answer went up here. What was this answer, anybody? Yeah, and I'm not feeling comfortable that I did that one right, but I'll come back to it. In how many ways can a group choose a committee of 4 boys and 4 girls if there are 20 boys and what did it say underneath there? Okay, so 20 boys and we're going to pick 4. It's a committee, so definitely order doesn't matter. And then there's what? 15 girls, and we're also going to pick 4. All right. And then we're going to multiply those together because if there's 17 ways we can do this and 17 ways we can do this, then we could have a lot of differences. I don't know what this comes out. Anybody get an answer?
I got it.
Like that? Anybody else get that? A lot of ways. All right. So I assigned yesterday all of 3 and 4A, the circled problems, and now you can also do 4B, 5B, and all of 6, the circled problems. Did anybody look at anything and have any questions last night? I know most of you didn't even look at them, right? We can go back and talk about them later. We have like 2 days to review for the quiz next week after the SAT is over. So, all right, I'm going to stop the video.